CO new material has developed a new type of intumescent flame retardant H112D. H112D intumescent flame retardant. It is an environmentally friendly green flame retardant. Appearance: white granular form. Color stability without discoloration. Compatible with various emulsion series. Does not affect construction performance and is halogen-free. Does not use antimony trioxide as a synergist. The system itself has synergistic effects. It has excellent flame retardant and thermal insulation properties. Produces low smoke, non-toxic, and non-corrosive gases. According to the formula, expansion-type fireproof coatings for steel structures were prepared separately. The two samples on the right are made with H112D expansion flame retardant. The two on the left are made with ammonium polyphosphate, penterithrotol, and melamine composite flame retardants. Both coatings were applied with the same thickness. They were placed in a 52 degrees C oven and dried simultaneously for 24 hours. The product on the right is the fireproof coating with H112D expansion flame retardant after drying. The product on the left is the fireproof coating made with ammonium polyphosphate, penterithrotol, and melamine composite flame retardants after drying. Simultaneously, drops of tap water of the same quantity were added to both samples. They were placed in the oven until the water had completely evaporated. We can clearly observe that in the sample with ammonium polyphosphate, penterithrotol, and melamine composite flame retardants, there is a noticeable precipitation at the water drop spots. However, in the sample with H112D expansion flame retardant, there is a black ring in the middle. This occurred because the water brought the pigment to the surface during drying without showing any white crystalline precipitate. According to the formulations, the Intumescent fireproof coatings for steel structures were prepared. On the left is the fireproof coating with the H112D expansion flame retardant after drying. On the right is the fireproof coating with ammonium polyphosphate, penterithrotol, and melamine composite flame retardants after drying. Both coatings have the same application thickness. Simultaneously place them into small buckets filled with the same amount of tap water. Observe the state of the two coatings over 48 hours. It is clear that the coating with ammonium polyphosphate, penterithrotol, and melamine composite flame retardants has completely separated and peeled off from the substrate in the immersed parts. In contrast, the coating with the H112D expansion flame retardant shows no detachment. H112D expansion flame retardant is mainly used in intumescent fireproof coatings for steel structures with excellent water resistance and weather resistance. The expansion principle of H112D expansion flame retardant is that the coating softens or melts when heated. H112D expansion flame retardant itself generates gas and decomposes free acid and polyo and dehydrates and esterifies. As this process continues, the generated gas escapes, causing the softened coating to foam and expand. Increasing in volume, the expanded foam layer gradually transforms into a carbonized, insulating layer. As the reaction nears completion, the system chars and solidifies, ultimately forming a porous carbon foam layer, preventing oxygen from entering the combustion area, inhibiting degradation, and preventing gaseous or liquid products from escaping the material's surface, making it difficult for heat to penetrate, thus achieving the effect of flame retardancy and thermal insulation.